Yes, good evening. Welcome to Let's Crack CBSE Science. So let's wait for a few more minutes for the others to join and then we'll pitch in. So we have been looking into the CBSE Class 12th Computer Science, and right now we are into the topic of data structures, wherein we completed stacks. We had a couple of classes with regards to stack, wherein we discussed the different operations followed by the applications. Okay, and then we also learned the worked out examples of stack applications, wherein a few questions were discussed too. And today, the title is very clear to you. Today, we'll be learning on the next data structure as per the NCERT syllabus, which is the queue. So we'll just wait for one more minute and then we'll pitch in. So, yes, good evening, Google. Good evening and welcome to my class. Yes, it's time, and so let's start. Okay. So, a very good evening and welcome all of you to Let's Crack CBSE Science. So, before moving on to the lessons, let me give you a self introduction. Hello, I am Shalini. I'm a BTech and MTech holder in computer science and engineering, a teacher by profession with over 14 years of teaching experience, teaching various BTech undergraduate students in various disciplines of engineering. With Unacademy, I'm excited to provide an inspiring learning experience to all the um, students via this online platform. Now, a few words on Unacademy. Now, Unacademy is not something very unfamiliar to you. It has grown out to be India's largest e-learning platform, not because of the reason of the pandemic situation, but also for the reason that it is a one-stop destination for be it a school-going CBSE student or be it an aspirant who is preparing for the competitive examination. You get every courses underneath an academy, so it's somewhat like a one-stop destination. And for this reason, it has grown out to be India's largest e-learning platform. So, what you get in an academy, you get access to daily live classes. Now, all the courses offered in an academy are well structured and from the good and top educators from all over India. There are live tests and quizzes which would help you to evaluate your performance and then you have unlimited access provided you get a subscription of Unacademy. Now, in the daily life class, you get an opportunity to chat with the educator, engage in discussions, and ask your doubts and answer via polls. Now, all the facilities while the live class is going on. Now, if you miss out a live class, you needn't worry, because once you get a subscription, you get access to all the resources, say live and recorded classes. Now, which can be viewed at the comfort of your time as well as at the comfort of your device. Okay. Now you have live tests and quizzes which would evaluate your performance, your preparations, and gives you an analysis of your performance. Just a second. Okay. I told you that all the courses here are well structured. That means they are in line with the current examination syllabus. So this would help you to prepare better for the forthcoming examination. So next, this is the comprehensive syllabus. So this is how the syllabus would look like for a CBSE student. You would have the different subjects, and underneath each of the subject you will have the courses which are offered by the various educators. You can click on the courses based on your choice and then listen to the classes. Um, Now, this is the Unacademy Learning app, which you need to download from the Play Store and install in your smartphones. So I repeat, this is the Unacademy Learning app, which you need to download as students. You need to download from the Play Store and install in your smartphones and get the subscription as per your choice. Now there is a Telegram app, a Telegram channel too in the app. All you need to do is download the app in your smartphones and see the link that is being shown here. You just need to type the link in the URL and click to join. So wherein you can join to the channel. So here you get updates about the materials and classes posted by the various educators. The channel is Quest 12 CBSE Commerce for Unacademy. And here is the most important slide wherein you get the details about the CBSE Class 12 subscription fee details. Now, there are two tables shown here. Now, each of the table consists of different plans. Now, across each of the plan, you have the amount also. Amount also listed. A month subscription ranging from 2,500 to a year subscription which cost you around 12,500. But if you apply my referral code or my promo code SLYT, I repeat, if you use my promo code SLYT, you get a discount of 10% on the subscription fee. That is the fee which was costing you around 2,500 for a month subscription. After applying my promo code would be, after 10% deduction or discount, would give you only 2,250. So similarly, the discount varies, can be applied on all the below plans that is being shown here. So I would recommend, if you are a class 12th or 11th student, I would recommend you to definitely take up a 6-month subscription or a 12-month subscription as per your need. And then you can also switch over to the competitive examination. Yes, Adarsh, good evening and welcome to my class. Just a second. Okay. So these are the details regarding the subscription fee. And then Moving on to our agenda. As I told you, we are dealing with the CBSE Class 12 Computer Science. And today we'll be learning about the data structures queues. Okay. So which is the data structure that we're going to learn today? We're going to learn queue today. So these are the contents that we'll be covering in today's presentation. So we'll be looking into the this is not the revision class, Adarsh. This is actually the full chapter content. We had covered with the stats and now we are learning with Qs today. Okay. So we had a couple of classes wherein we had learned about stack. We had in the last class we had certain worked out examples being discussed regarding the stack application, and today we'll be learning with Qs. Okay. So shall we move on? Yes, it's in the data structures chapter. Okay. So these are the contents that we'll be covering. We'll be looking into the definition of queues followed by the different operations, queue operations and the terms associated with queue, the certain terms associated with queue. Yes. And then we'll be looking how to implement queue in Python, if not the entire code, at least how the different operations could be performed, and we'll be looking the sample codes or via the user defined functions. And finally, the real life examples for applications of queues. Okay. So let's get to learning. So the first thing that we're going to learn is the definition of the data structure queue. Okay, so what are we going to learn? We're going to learn the definition of queue. So we're going to learn definition of queues. So what are queues? Queue is a linear data structure. Okay, what does the word or terminology linear data structure means? It grows in a linear fashion or in the form of a line. Okay, so the elements are added. You see how the line grows, right? So similarly is how the elements would be added up in the queue and how this would be deleted also. Now we're talking about the growth of the data structure. So this happens in a linear fashion and hence the name linear structure. Okay. So this linear structure is implemented in FIFO manner. Now we had talked about stack and we learned that stack was implemented in which order or which was the technique used. The technique used was LIFO, right? Last in, first out. But when you're talking about queues, it is a data structure. It is again a linear data structure, but it is implemented in FIFO order or FIFO technique. Now, what is FIFO? FIFO is first in, first out. Okay. Now, here how the insertions take place at an end called as the rear end, or you can call it as a tail end, and deletions are restricted to only front end of the queue. Okay, so you have a data structure and this name of the data structure is queue. Now what is the manner or the property of the data structure? It is implemented in FIFO manner or first in first out manner. Now, the insertions and deletions can happen in the data structure. Now, what is the restriction? The insertion take place at rear end and the deletions are restricted to only the front end of the queue. Okay. Now, a queue has two ends. Now, which are the two ends? As per the definition, the two ends of the queue are rear end as well as the front end. Now the rear end items to the queue are added from this end and the front end items from the queue are removed from this end. Now let us take an example of a queue counter, a ticket counter. Now you have, now imagine that this is the ticket counter and you have people standing here, okay, for taking the tickets. Now, how do the people stand? I mean, they'll be standing in a line, right? Now, the person who is in the front or just above the just in the position next to the ticket counter is supposed to be the person who would be coming out of the queue first. Okay, so he entered the queue also first, and as well as he comes out of the queue also first. Now, what if already there are three people in the queue, and what if one more person comes to the queue? Now, this person would be added towards the last end, right? So, this end is called as the rare end. So, whenever an item is added, we call that end as rare end, and whenever we delete it, we call it as front. So, the person starting in the front will be coming out of the queue because he will be the first one to get the ticket, purchase the tickets, and he'll be the first one to come out of the queue, right? So here, hence, rear and front end. Okay. So moving on, let's see what are the different operations with regards to the queue. Now, as I told you, there can be insertions wherein you can add an element to the queue, as well as there can be deletions from which an inserted element can be deleted from the queue. Now, the terms associated with insertion as well as deletion are NQ for insertion and DQ for deletion. Okay. Now, a new data can be added only to the rare end of the queue. Now, we already saw this in the definition that the insertion to the data structure queue can be done only through the rare end. And sorry, it is not the stack, it is the queue here. There's a small mistake. Okay. Insertion of an element in a queue is called as NQ operation, and removal. Now, from which end is the removal happening? Removal happens from the front end. That is the element at the front end of the queue. And this removal activity is called by the term DQ. Okay. Now, when we considered stack, what was it? Stack was following a LIFO technique wherein the last inserted element came out of the stack first. Okay. Now, what was the name associated with the insertion and deletion? The names associated were push as well as pop, right? And how about the ends of the stack? It could access all these operations could be done only through one end, and that particular end was called as the top of the stack, right? Now, when you consider the next data structure, that is queue, now we understand that queue is a data structure which follows the FIFO technique or first in first out technique. The different operations associated with the queue are NQ as well as DQ. Okay, NQ and DQ. Now, NQ is nothing but insertion of an element to the queue, and DQ is deletion of an element from the queue. So, these are the associated terms when you consider both insertion as well as deletion. Okay. So, I would once again like to make this correction. This is queue and not a stack. Okay. Now, let us see the different terms that are associated with the data structure queue. Okay. Now, the terms are peak, overflow, and underflow. Okay. Now, peak is nothing but sneak peek, wherein you are peeking to find out what is the element in the front of the queue. Now, how did peek act in stack data structure? It peeked to see which is the element that is appearing in the top of the stack, right? Similarly, peek refers to inspecting the value at the queue's front. Okay, so without removing it, it is also referred to as inspection. Now, see the term associated with peek. Now, the other term for peek is inspection. Okay. Now, the other terms associated with queue are overflow and underflow. Now, overflow refers to the situation when one tries to enqueue an item in a queue that is full. Okay. So, when is an overflow situation encountered? when you're trying to insert, NQ meaning you are trying to add an element to the queue or insert an element to the queue. So when you're trying to insert or NQ an item to the queue and the queue is already full. Okay, so in such a situation, there is no more possibility of insertion or what situation occurs, the situation occurred is called as overflow. Okay, the queue is full, and then if you're trying to attempt adding a new element, what situation arises? Overflow situation arises. Now, this situation occurs when the size of the queue is fixed. Okay, so when does overflow occur? Overflow occurs only when we have a prefixed size defined for the data structure queue. Okay. Now, next is underflow. Now, underflow refers to the situation when one tries to dequeue or delete an item from an empty queue. So, what is underflow? Your queue is already empty, and now in an empty queue, you are trying to attempt or you are trying to delete or dequeue an element from the queue. Now, what would come up then? Underflow situation. Is the idea clear? So these are the terms associated with queue, which are the terms peak, overflow and underflow. Actually, the terms are familiar to us because we had already come across these terms with respect to the data structure stack, right? In stack also we saw the same terms, but the conditions were different. See, in the case of stack, we always were peeking and finding out the element at top of the stack, right? Now, with respect to queue, we are trying to peek and find out the element that is at the front of the queue. Now, we are not trying to remove it, we're just inspecting it. So, hence, the another name for peek is nothing but inspection. Okay. Now, overflow is a condition in which your stack is full and then you are trying to insert an element. Now, when does a situation of stack full arises, sorry, a queue full arises? A situation in which you have a bounded queue. That means bounded in the sense the capacity is already told and only that many number of elements can be added to the queue. Okay. Underflow, it refers to the situation when one tries to delete an element from an empty queue. Okay. So moving on. Now let's see an example. Now we are given with a bounded queue. Now what does bounded means? You have a definite size for the queue and only that many number of elements can be inserted to the queue. So you are given with a bounded queue of capacity 4. So how many elements can be inserted here? Only 4 elements can be inserted. Now which is initially empty. Okay, so what does it say? It is initially empty in the sense that the queue has no elements in the first case. Now you are asked to draw pictures of the queue after each of the following steps. So ones that are given in a small letter Roman numbers are your question, and based on the question you have to show the status of the queue. Okay. So I have drawn tables here to show the queue data structure and how the elements would be added up as well as deleted. Now for each of the elements there is a position number associated with the element. The values are 0, 1, 2, 3, etc. What are they? They are the index or the position values. Now we know that there are two variables associated with a queue, which is front as well as rear. Okay, what are the values associated? Front as well as rear. Now, in the initial case, what is to be shown? We have to show that the queue is empty. Okay, now to show the queue is empty, first we need to see or associate the value of the variables associated. Now, what are the variables associated with the queue? We have front as well as rear, right? Now, this has to be assigned to the legal empty value in Python. Which is the legal empty value? The legal empty value in Python is none. right? No, any, none. Now, what happens? We have the different position values also. Now see here, the position values have ranged from 0 to 3. So how many values are being shown here? Just 4 values. Why? Only 4 index values, because in the question it has been given that our queue is bounded and the maximum capacity is 4. So how many elements can be inserted here? Only 4 elements. Okay. So in the first case, the front and rear is assigned to none, the legal empty value of Python. And see, the our queue looks empty. All the positions are vacant here. So this is the first case wherein the queue is empty. Okay. Now let's see the next operation. Now what is being asked? NQ of A. Okay. Now what is NQ? NQ meaning insertion. Okay. So we need to understand that NQ is insertion and DQ would be deletion, right? So these are the terms associated with it. So when you're trying to say NQ of A, now what is to be done? You are trying to insert an element into the queue. Now what is the element? The element is A. Okay. So whenever you're giving an insertion operation or whenever you're giving NQ, what you have to do is you need to give the element also that is to be inserted. Is the idea clear? Whenever you're doing the NQ operation, the item to be or the value to be inserted also has to be specified. But when you're trying to give deletion, you just need to specify that DQ operation to be performed. You're not trying to delete an element from a particular position number. Instead, you're going to delete an element from the front. Okay, whichever element that is pointed by the variable front would be deleted. So this is something that we need to keep in mind. So which is the next operation? The next operation is NQ of A, right? Now in NQ of A, now this is the very first element that is going to be inserted, right? So what would be the values of front and rear? Priorly the front and rear was pointing to none because the queue was empty, and now we have a single element which is to be inserted and the element is A. Now where will this element fall? At index value 0, right? So front and rear has to point to the single element right now in our queue. So the values of front and rear should be initialized to 0. See how F and R is pointing to? It is pointing to the element A, wherein A is at index position 0. Is the idea clear? Now, which is the next operation to be done? NQ. NQ means insertion, right? So when you have to do NQ operation, you have to specify the item or the value to be inserted. Now, what is the value to be inserted? The value to be inserted is B, right? Okay. So in this case, what happens? We have learned as per the definition of Q that the elements would be deleted from the front, but the elements are inserted through the rear end. So which is the variable that has to progress? Definitely the variable to progress is R, or the rare, right? So what would happen when you are trying to insert the next element B? It would be inserted at the very next position after A. That means at position 1. So front will always point to the very first element inserted, which is A. Now you needn't bother about changing front now. Okay. Now, what is the thing that has to be taken care of? You need to change the value of rare, right? So, at what position rare would be moved to? Rare would be moved to the position number 1, and hence it would be pointing to the element B. Okay. Now, let us see the next operation. So the next operation says again NQ. So what is NQ? NQ is definitely insertion. When you have to insert, you need to specify the element. Yes, the element has also been specified. What is the element? The element is C, right? So the new element would be inserted here at the position 2. Okay. So priorly, do you have to change the value of front here? No, because front would be pointing to the very first element in the queue. Now, where would rear point to? Rear would point to the position number 2. So, R points to 2, wherein the element C is inserted. So, as you are inserting the elements, you need to take care of incrementing the value of rear and not the value of front. Is the idea clear? As you start inserting elements into the queue, what you need to take care of is you need to go on go on changing the value of the variable rear and not front. So at the first case, when the queue is empty, both the values would be assigned to none. But as the elements get inserted, when it is the very first element which is inserted, both front and rear would be pointing to the position value 0. But as elements gets added up in our queue, the value of the variable rear gets incremented, but the value of the front will always be pointing to the very first element in the queue. Okay. Now at this stage, which is the fifth operation initiated, it is DQ. Okay. So the fifth operation is DQ, wherein the value of front is 1 and the value of rear is equal to 2, right? Why? Because when you're trying to DQ means you're trying to delete an element. Now what happens when you try to delete? The element pointed by front would be deleted. So F was pointing here, the element was A. Now see, what is the element A present in this position? No, it has been flushed off or removed from this position. And now after removal, you change the value of front but not the value of rear. So this is something that you need to take care of. Now after the deletion, what happens? The value of front is being pointed to position number 1 and rear would be pointing to position number 2 itself, like this. Okay. So front, now the new front of the RQ is B because the element in the position 0 has been deleted using the DQ operation. So moving on, we have the next operation. Now what is the next operation? The next operation is NQ and NQ of D, right? Now what does NQ say? Just a second. Okay. I think there is some problem here. I pen tab. Yes, it got rectified. Yes, so the next operation is NQ of D, right? Here we are trying to insert, and which is the element to be inserted? The element to be inserted is D, right? So where will it be inserted? To the very next position after at the new rear value. What is the new rear value? The position 3, right? So when you're trying to insert D, the rear takes the value 3 and there is no change in your front, whereas front now pointing to 1. Okay. So this is the case. Now, what was our bounded capacity value of the queue? It was 4, right? Now, at this stage, though you have deleted one element, our new front is pointing to the element at position 1 and the rear is pointing to the position 3, and in this case, our queue is full. Okay, so this is the problem with the queue. At this stage, our queue is full. Fine. So now when you're trying to insert an element, say E, into this queue, what happens? You will not be able to insert it. Why? Because here there is an overflow, because the queue is bounded. In Python, the queues are implemented using list. Since list can grow, overflow condition does not arise. Now this is something that we're going to learn with respect to Python, but since in this example we are given with a bounded queue, that means the capacity was already mentioned, we need to understand that when the queue is full and we try to insert a new element, what is the condition arise? The condition arised is overflow. But in our language Python, the data structure queue would be implemented with list, wherein such a condition is not going to arise. That means you can keep on adding the element to the queue, and the queue can grow, because the property, as per the property of the list can grow. Okay. Now, when you're trying to dequeue, what happens? Currently, your front is pointing to B, right? Now, if you're trying to dequeue, which element would be deleted? The element B would be deleted. And now, the value of the front has to be changed. Now, it would be changed to point to C. Okay? So, one thing that you need to keep in mind is, when you're trying to insert an element, the value of rare gets changed. Whenever you try to delete an element, the value of the front gets changed in the case of a queue. Is the idea clear? So whenever you are trying to enqueue or add an element to the queue, what happens? The value of rare changes. When you are trying to delete an element from the queue, the value of the front changes. Okay. Again, when you try to dequeue, what happens? The element C would be deleted, and now your front and rear would be pointing to the element 3. Okay. Again, you try to dequeue, what happens? The last element, that is D, also gets deleted, and you end up with an empty queue. Okay. Now, what is the condition here? The condition is empty. And in the empty case, what are the values front and rear pointing to? Front and rear would be pointing to none. Okay. So, these values are pointing to none because there is no value inside the queue. So, now at an empty situation, when you are trying to perform a dequeue, okay, there is no problem if you're trying to insert a value, but in an empty situation, when you're trying to dequeue or delete an element from the queue, what happens? Underflow situation occurs because the queue is empty. Here, the front and rear are both equated to none. Is the idea clear? So this is how the enqueue as well as the dequeue operations are performed in the data structure queue. Is the idea clear? In the initial state, both the front and the rear are always initialized to none. When it is a single element, the very first element to be inserted in the queue, what happens? The front and rear would be pointed to the value or equated to the value 0. Now, as you go on adding elements to the queue, you need to change the value of rear. As you go on deleting the elements from the queue, you need to change the value of the front. So, this is how the data structure queue would be working. Okay. Now, let's get into learning of how to implement queues in Python. Okay. Now, what are we going to learn? In the language Python, how do we implement queue? Okay. So, Python uses list for implementing queue. So, what is the thing that we use for implementing queues here? We use list. Okay. So, for the various queue operations, we need to understand what are the different methods or code used in Python. Now, the first thing we need to understand is we are implementing queue using list, right? So, we need to understand the methods of the list for performing the various queue operations. So, let us first see the first operation. What is the first operation? The first operation is peek, right? So for peeking means just visiting or just inspecting the element pointed by front, right? So Q is your name of the list and Q of front, and front illustrated or enclosed between square bracket. Now this would look like the index value, okay? Now whatever is in the index value pointed by front, that particular value will be addressed, and if you want to print it, you can print it. So where here Q is a list and front is an integer storing the position of the very first value in the queue. Is the idea clear? Wherein Q is a list and front is an integer storing the position of the very first value in the queue. Okay. Now, which is the next operation? Next operation is insertion or NQ. The term associated with insertion is NQ, right? So Q dot append of item. Now, append is a method used for adding an element to the queue. Okay. So where item is a value being pushed in the queue, or item will be added to the which end, it would be added to the rear end. We know that the append method always adds the element to the tail end of the list, right? So you needn't bother about it because the rear is always pointing towards the tail end, and in this case the elements that would be inserted in the list would definitely be at which end? It would be at the rear end. Is the idea clear? Now, how about the next operation? Next operation is deletion or DQ. Now, which is a method that is used for deletion or taking and removing an element from a list. Pop, right? So here again, we use the method pop for deleting the elements from the queue. So how do you write it? Q dot pop of front. Okay. Now, so the element pointed by the front at the index value front would be popped out. Okay, so as you change the value of front, so will be the pop element. So this method would be returning a value. Now this value would be the value that is deleted. In the program, you can save it to a variable and then print the variable to show which is the element that you have popped out from the list or that you have deleted or removed from the list. So I hope the functions or the methods are clear to you. How to implement Q in Python. Peek of an inspection, what do you do? Whatever is a value that is being pointed by the variable front in the list named Q, that could be printed. If you're using it inside the print function, that would be printed onto the screen. Next is NQ. Okay, NQ is nothing but adding an element to the queue. Now, how do you add it? Using the method append of item. Okay, so whatever you are specifying inside the function append, that particular value would be added onto the queue. Now, where will it be added? It will be added at the tail end, or which is called as the rear end. Okay. Next is DQ. DQ is nothing but deletion. How is the deletion done? Using the method pop. Okay. So I hope the methods are clear to you because we have already seen this method when we learned list. Okay. Now number of elements in the queue. It would be rear minus front plus 1. Why plus 1? Because the index value always starts from 0, right? So the number of elements would be rear minus front plus 1. Okay. Now Python queues are implemented using lists that we already know. The very first element or the element at index position 0 would be the one that is pointed by front. So what would be the value of front? Front would be 0. And as you delete the elements, what would happen? The value of front gets changed. Okay, it would be changing. Now, what is rear? Rear always points to the last element. Okay, it is the position in which a very new element could be inserted. So len of the queue, what would it return? It would give you the count of the number of elements in the queue, right? So the number of elements in the queue minus 1. Why minus 1? Because the index value is always starting from 0. So the total count minus 1 should be initiated to rare. Now the same case why we incremented 1 for finding the number of elements. Okay. So these are the things to be kept in mind. What are the code for implementing the different operations? Now, what are the operations? The operations are peek, NQ, and DQ. Okay, and then the calculation of the number of elements and the assigning for the values of front as well as rear. Now let's see the NQ operation. Okay, so just a second. So NQ meaning inserting an element into a queue, right? So how do we insert an element to the queue? Now we already learned that queue would be implemented using list, okay? So list is nothing but a sequence of values separated by comma and it is enclosed between square brackets, right? Now, NQ, now we're going to write a function, user-defined function for performing the NQ or insertion operation inside the queue. Now, I told you whenever you're trying to perform the insertion or NQ, you need to specify the value which is going to be inserted or the item that is going to be inserted, right? So, DEF, the keyword, followed by the name of the queue, and then inside the bracket, you would have the Q comma the item. What is Q here? Q is the name of the list and item is a value that is going to be inserted in the list. Okay. Now why did you give colon here? Now this shows that you have a compound statement following, or it shows that this is the body of the queue is going to follow. Okay. So Q dot append. Now Q dot append of item. So what would happen? The value that is pointed by the variable item would be added to the tail end of your list. Now which is a list? List name is Q. Okay. Now after adding the element, what is to be taken care of? You need to take care of what will be the value of the variable front as well as the value of the variable rear, right? If the len of q is equal to 1. Now what does this statement indicate? Len of q means the count of the number of items inside your list, right? Now if the number of elements inside the list is 1, so that means the element that you inserted right now is the only element inside your queue, or your queue was priorly empty and this is the very first or debut element to the queue. In that case, what should be the assignment to the variables front as well as rear? Both front and rear should be initiated to 0. Is the idea clear? The case in which the inserted element or the item is the only element in the queue. In that case, both front and rear has to be initialized to 0. Otherwise, what should be done? The value of the, so otherwise means what? So this item is not the only element. There are more elements, right? So in this case, you need to, after inserting, you need to change the value of rear. Now, how would the value of rear be changed? Len of q, that means the count of items in the queue minus 1. Is the idea clear? So this is how rear would be changed. So this is the function, user defined function, which would explain the NQ operation or how to insert an element inside the queue. Now what is to be taken care of? You need to specify the value or the item to be inserted into the list queue, right? So q dot append of item. So if len of q is equal to 1, so that means if this is the only element inside the queue, the value of front and rear has to be initiated to 0. Otherwise, it shows that this is not the single element. You have more elements inside the queue. In that case, which is the variable that you need to change? You need to change the value of the variable rear. Okay. So, moving on. Which is the next operation? The next operation is DQ. DQ means deletion, right? So deleting from a queue. So DEF, DQ of Q. Now this is a user defined function. What does DEF say? It is that the function body is going to start, or function definition is going to start. The name of the function is DQ, and which is a value that you are passing here as parameter, the name of the list. Now, when you're trying to delete an element, can you delete an element from an empty queue? No, right? You cannot delete when it is an underflow situation. Yes? Yes, good evening, Amritesh, and welcome to my class. So, first you need to check whether the list is empty. If the list is empty, what is to be printed? You print the value as underflow, right? Now, after that, if it is not empty, so that means definitely there are elements inside the queue and which can be deleted. Now, how do you delete an element from a list? Using the method pop, right? Using the method pop. So, else item is equal to q dot pop of front. Now, whatever is the element that is being pointed at the index position front has to be popped out. Now, how do you use pop method inside the list? You can either give the index value or you can simply give pop by omitting the index value. Now, I have used the version of pop by showing the index value. Now, this value at this particular position has to be deleted, right? Now, if I was simply giving pop without showing any index value, what would have happened? You would have ended up deleting an element at the very last position. That means anything that is pointed by rear. Now, is that the case that you want here? No, right? You want every time to delete the element which is pointed by front. So, how do you give it? Q dot pop of front. Okay. Now, after deletion, what is the thing to be taken care of? You need to alter the value of front as well as rear. Okay. Now you check to see if you had deleted the only element that was inside the queue. So if that was the only element, that means now after the deletion you have ended up in an empty queue, right? Now what is the status of the queue? The queue is empty, and len of q is equal to 0 means the front and rear has to be initialized to the legal empty value in Python, which is none. Is the idea clear? So when you're trying to delete, you try to check after deletion, was it the only element that you have deleted? In that case, front and rear has to point to none. Now prior to deletion, what you need to check? Whether your list is empty. In that case, what would be printed? The message underflow would be printed on the screen. Okay. So we have right now seen the method enqueue followed by DQ. Now what are we going to see next? We are going to see the peek operation. Now what does peek say? Peek is inspecting. Now whatever value is present in the front of the queue, now that particular value would be printed on screen. So how do you print it? Queue or the list of front. Now front as the index value, right? So see here, you're again going to write a user defined function. How do you write a user defined function? With the keyword def followed by the name of the function, and then you have the name of the list as parameter. Now inside this function, if the queue is empty, can you print the value and pointed by front? No, right? So first you check whether the queue is empty or whether your list is empty. In that case, if it is empty, you give the message underflow printed on the screen. Otherwise, what does else show? Your queue is not, or queue or list is not empty. Instead, it has elements inside the queue. So what would be given? What would you do? You would change the value of front to 0 and then print whatever the element is pointing to at the position front. Is that clear? So next is display. So next function is display. Now what happens in display is you have again write a user defined function for displaying the elements in the queue. Now what are the things that you need to take care of here? If it is an empty queue, you needn't print any elements, just print the message that the queue is empty. Now how do you check it? Because since we are implementing the queue using a list, we check whether queue is equal to empty square brackets. In this case, we print queue is empty. Otherwise, there are two things to be done. I mean, two things to be checked. That is, if you are trying to print an element from the queue and you find that this is the only element in the queue. Okay. Now, how do you check that? Len of queue is equal to 1. So that means the number of elements in the queue is definitely 1. You have only one element in the queue. In that case, what you need to do is just print whatever be the element that is pointed in the position number 0. And when you know that this is the only element in your queue, what happens? Both front and rear would be pointing to this element, right? Now suppose in your queue, I mean, you have a 3-element queue and the element at the index value 0 is 3. So how would this be printed is you would have the element queue of 0 printed on the screen and then you would have this pointer and then the message front comma rear. Now what does this show? This shows that both front and rear are being pointed to the value 3. Is the idea clear? So queue of 0, that means the very first element in your queue, which is 3. Is the idea clear? Now, when will this else be executed? When both the if and else if condition goes false. So that means neither the queue is empty nor the condition that the queue has just one element. So that means it is having more elements in the list. In that case, you need to print all the elements and also you need to indicate which is the element pointed by front and which is the element pointed by rear. Now, how do you do it? You initiate the value of front to 0. After that, you initiate the value of rear. Now, how would the value of rear be initialized to? Len of q minus 1. That is the count of the elements minus 1. Why minus 1? Because your index value starts from 0. Okay. Now, first you would print the element that is being pointed by the variable front. So, q of front and the indicator that this is where the variable front is pointing to. After that, you would print all the values from starting from the position 1. So, whatever in the 0 index would be printed here, right? So, the elements from the range 1 to rear minus 1 would be printed in the loop. In which loop? In the A loop. Okay. So A is your loop variable and it is using the range function. So what is the range of values that it will be taking from value 1 up to incrementing up to rear minus 1. It would not be considering rear. So all these values from position number 1 till rear minus 1 would be printed by the loop for loop. And when you come out of the for loop, what would rear be pointing to? Rear would be pointing to the very last element, right? So you print the very last element and then give the indicator and rare. Okay, so this is how you would be displaying the elements in the queue. First, you check whether your queue is empty. If the queue is empty, I mean the list is empty. Once the list is empty, you can conclude that your queue is empty. You print it. Now, whatever is being pointed by 0, and if you find that this is the only element in your queue, so queue of 0 would be printed on the screen, and you would point front and rear to queue of 0. Otherwise, there are more elements in the queue. In that case, you would start printing all the elements from the position front to the position rear. But you need to mark which is the element that is pointed by front and which is the element that is pointed by rear. For this case, you have chosen the printing like this. Is the idea clear? So hence the display function also. So with this, now we're going to see the different queue applications. Now, usually we see the queue applications in real life in many situations. Also, say for example, in the airport authorities, they make use of something called queue, where when you are sharing a single runway of airport for both landing as well as takeoff. Now, in similar situations, in almost all areas in the real life, we use the technique of queue, that is last in, first out. Okay, sorry, first in, first out. The technique first in, first out is being used for the queue. Fine. Now, apart from that, we see that the structure or the technique or the manner utilized by queue is being used in by the operating system as well as by the CPU or our processor. See here, sharing of one resource among multiple users, such as shared printer among multiple computers. Now imagine that there are a couple of students who is working in a lab, and everybody has to print the program that is being typed on their respective system. In that case, you have just one shared printer. So whoever who initiate the action print in the first would be printed by the printer. Now, what is the print action or how is it accumulated? It actually takes the form of a queue. Okay. Now, every queue initiated operation from each user would be coming in a linear fashion, that is one after the other, and it would be appearing in the form of a queue. The one that has come first, very first, would be printed first by the printer. Now this would be saved in the buffer of the printer, and in each case the buffer is checked for the position, and the value in the very first position would be printed. Is that clear? So this is how we use it in the case of an operating system, and in the case of processors, the queue are used to implement round-robin scheduling among waiting processes. Round-robin scheduling in the case that you have number of processes which is going to be executed. In that case, the processor has to cannot devote the entire time for a particular process. What happens is, if it gives its entire time for a particular process, and if this particular process take a team time for its execution, what happens? All the other processes would keep on waiting for its service to be for it to get a service of the CPU, right? In that case, what it does is it uses a scheduling technique which is called as round robin. In round robin, a fixed time quantum is being associated with each of the process. So what would happen? Process P1, in case if it is given 5 minutes, for the first 5 minutes, processor would be in P1 and it would be executing P1. After that, the next 5 minutes, it would be in process P2, and after that P3. Okay. Now imagine that these are the only three processes in your system. In that case, what would happen? After execution of P3, 5 minutes, the control would again go to P1. the 5 minutes would again be devoted to P1, P2, P3. So similar fashion, this would be happening. So the CPU uses queue to implement round robin scheduling among the waiting processes for it to be executed. So these are very usual cases or real-time examples wherein you use the data structure queue. Okay. Now, apart from the queue that we have learned just now, there is a variation in the queue which is called as circular queue as well as double-entered queue or DQ. Now, when we learned queue, we saw that suppose this is a 3-element queue, okay, and you have position 0, 1 and 2. This is your queue. Now, your front points to the very first element and rear would point to the very last element, right? Now, in this case, what would happen? Suppose you delete an element, the elements get deleted from the front, right? So, the element at position 0 would be deleted, and then where would front point to? The front would point to here, right? Now what happens? When you delete an element here, this element, this space becomes empty. But now you're not have in a position to enter a new value in this position, right? So in this case, you are not utilizing the space of the queue. Now this problem can be rectified when you are using the concept of circular queue. Okay. Now the queue is not in a linear fashion, but instead in a circle. Okay, so there is no question arises of an empty position. Okay, here all the positions can be filled in the case of a circular queue. The next version is double-ended queue or DQ, in which there are both ends for the queue and wherein you can insert as well as delete from both ends. Now there are actually two versions for DQ. One is called as the input restricted DQ and the other is called as the output restricted DQ, wherein you give a restriction to either inputting, that means entering a value, or you're giving restriction to output or deleting a value. Hence, there are two versions for the DQ. So these are the two variations in Q. Okay. So with this, we have come to the end of today's class. So to summarize what we have seen in today's class, we learned about the data structure queue. Okay. So queue, the different queue operations, the different terms associated with the queue, how to implement queue in Python and the real life applications of queue. Okay. So that was a very simple topic. And with this topic, we wind up today's session. So we would be coming in the I would be coming up in the next classes with the yet another topics that are to be covered in the CBSE class 12. So bidding all of you a good night. So before winding up, let me remind you of my promo code SLYT, which would help you in getting a 10% discount in the Unacademy fee subscription. So good night and hope to see all of you in my next class. Thank you.